Now we're going to take a look at a design consideration when using the flyweight pattern, and that is limiting the number of flyweight objects. If you just use the new operator, you might unintentionally end up with more flyweight objects in your program than you anticipated. So you have to control the flyweight creation process, the flyweight object creation process. That's especially true if you have multi-threaded code, which means that you might be using the new operator in more places than you intended. So the way to fix this is, much as you saw with the singleton design pattern, you make the constructor of this new class, which we're going to call student threaded, private. That means that nothing outside the class can create new objects of that class. As well, we're going to create a private static object, a student threaded object called single object, when the program first runs. That's how this works. Private static student threaded single object equals new student threaded. So there's only going to be one object created in the entire program. That's going to be called single object. One student threaded object only, and that's going to be called single object. Okay, so that will limit the number of objects created. And since the constructor is private, you now have to use a method such as a getInstance method to return the actual object, the single object in the program, and you can say return single object like this. So the getInstance method is just going to return this already created object, the single object. That object was created when the program first ran. Okay, so that limits the number of flyweight design pattern objects you're going to create in your program. Let's test this out with a program called test flyweight threaded. And what happens here is that you have the information, the configuration information for the students. You calculate their average score, and then you create a student threaded object with a getInstance method. It's going to be called an object just called student. You configure that flyweight object. There's only going to be one such object in the program. That's what we're trying to confirm. You configure that object with set average score, set name, set ID, and set score. So this is going to be the Ralph student. So we're setting the student threaded objects to. Then we're going to print out the person's name and their, as you see there, student.getName and their standing, which for Ralph was minus 18%. And so that is going to confirm that we're dealing with the Ralph object. Then as well, there's going to be a worker thread in this application, which is going to call the getInstance method a second time. Now, if everything is working correctly, the getInstance method call here is also going to return the same object as before. So that's going to be the Ralph object, not a new object. Okay, that's what we're going to try to test, because we're going to print out in the worker thread the name and the standing of the student. So this print statement and this print statement should both print out Ralph and the standing of minus 18 in order to confirm that we're actually dealing with the same object, despite the fact that having called getInstance twice, as you see here. All right, let's give it a try. We are Java test flyweight threaded, and in fact, yes, even though the main thread and the worker thread both called getInstance, we're dealing with the same flyweight object. And you have successfully limited the flyweight object creation process so that only one flyweight object is created in the entire application.